So you're building an API, and you get to the part where you need to delete some data. It can feel like you're casting a really powerful and maybe even a little bit of a risky spell. Well, today, we're going to master that spell. We're going to dive into how to properly delete resources in a RESTful API using Express.js, and we'll do it all through the lens of a fun Hogwarts-themed system. Let's get right into it.
Here's our game plan. First, we'll nail down exactly what a resource is. Then we'll pick the right HTTP spell for the job. After that, it's all about practice. We'll jump into some real Express code with a hands-on demo. And finally, and this is super important, we'll cover the safety measures to make sure our code is solid and reliable.
All right, before you can delete anything, you have to know exactly what you're targeting, right? In the world of REST APIs, we call this a resource. You can think of it like finding the specific student you're looking for in the vast Hogwarts school records.
And here's the more formal take on it. A resource is basically any chunk of information you can point to a name. The real magic here is its unique resource identifier, or URI. So for our Hogwarts system, an endpoint like /wizard/123 isn't just about getting a list of wizards. No, it's targeting one single wizard, the one with the ID of 123. That URI is like our magic wand, pointed directly at the data we want to mess with.
Okay, so we can now target a resource. What's next? We have to choose the right spell. In HTTP, our main spells for changing things are delete, put, and patch. Now, they all modify data, but you've got to understand their very different effects. Let's break them down.
Let's start with the two update spells, put and patch. The biggest difference between them is just the scope of the change. Using put is like taking a student's file and completely rewriting it from scratch. You're handing over a brand new document to replace the old one entirely. Patch, on the other hand, is much more surgical. It's like you're just making a tiny edit, like changing a wizard's house from Gryffindor to Slytherin, but leaving everything else in their profile exactly as it was.
This table really brings it all together. Delete, well, it removes the resource, like expelling a wizard. Put replaces the whole record. Patch just does a partial update. But hang on, look at that last column. Idempotent? You'll see delete and put are yes, but patch is no. So what in the world does that actually mean? Idempotency sounds kind of complicated, but it's really just a fancy word for a simple but super powerful guarantee. It means you can cast the same spell over and over again, but it's only going to have an effect the very first time. Think about it. If you send a delete request for Wizard123, they're gone. If you accidentally send that exact same request again, nothing bad happens. The system state doesn't change because, well, they're already gone. The outcome is exactly the same, which makes our API predictable and way more robust.
All right, enough theory. Let's get our hands dirty and see how we can actually bring all these ideas to life. We're going to use the Express.js framework to build out the server-side logic to handle all these requests.
The flow is actually pretty straightforward when you break it down. First, our server gets a delete request for a specific URL, let's say /wizard/2. Then it has to extract that ID, the number 2, right from the URL. With that ID in hand, it searches our database for the wizard that matches. And this leads to a fork in the road. If we find the wizard, we delete them and send back a success response. If we don't, we send a not found error. It's just a clean, logical process.
Okay, time for a live demo. We've got a simple little in-memory database of Hogwarts students all set up. So let's walk through the actual code that's going to let us delete a wizard from our roster.
And here's our starting lineup. It's just an array of wizard objects. Each one's got a unique ID, a name, and a house. We've got Harry, Hermione, and Draco. For this demo, we're going to pretend we sent a request to delete wizard number 2, Hermione. This is line 1, inside our Express route handler. When that request for /wizard/2 comes in, rec.params.id actually holds the string 2, not the number. So we absolutely have to use parseInt to turn it into a number. This is a super common gotcha, and it's a critical step if we want to accurately match it against the number IDs in our database.
Next up, we have to actually find the wizard in our data. We're using the findIndex array method here, which is perfect for this. It just goes through our wizards array one by one. For each wizard object, which we're just calling W here for short, it checks if its ID property is a perfect match for the wizard ID we got from the URL. If it finds a match, findIndex gives us back the position, or the index of that wizard in the array. If it doesn't find anyone, it just returns -1. So, this if block is our success path.
If findIndex gave us back any number that isn't -1, we know we found our wizard. We then use wizards.splice index, 1, which is JavaScript's way of saying remove one element at this specific position. Poof, that's the moment of deletion. And to finish things up, we send back a 204 no content status. That's the standard, RESTful way of saying, hey, it worked and there's nothing else for me to show you. But what if we tried to delete, say, wizard ID 99, an ID that doesn't exist? Well, in that case, find would return -1 and our else block kicks in. We respond with a 404 not found status and, importantly, a helpful little JSON error message. This tells the person or program making the request exactly what went wrong. The thing you tried to delete isn't even here.
And there you have it, the grand finale. Before our delete request, the wizards array had 3 people in it. After we successfully ran that delete/wizards/2 command, Hermione's record is gone, leaving just Harry and Draco behind. Our spell worked perfectly.
Look, knowing how to delete something is one thing, but in a real-world, professional application, doing it safely is a whole other level of important. I mean, an accidental deletion can be an absolute disaster. So let's talk about the pro-level protections you really need to have in place.
One of the biggest professional decisions you'll make is choosing between a physical delete and a soft delete. What we just did in the demo, that was a physical delete. The data is gone forever. A soft delete is totally different. Instead of actually removing the record, you just mark it as inactive. Maybe you add an isDeleted true flag to it. The data is still there, just hidden from normal view. The huge pro here is that it's reversible and it preserves your data history. The trade-off is that your database queries get a little more complicated.
And here it is, your essential safety checklist. Seriously, you absolutely need a confirmation prompt for the user. That classic, "Are you sure?" box. On the back end, you have to authenticate who is making the request, and then you have to authorize if they have permission to delete that specific thing. Rate limiting is your friend to prevent abuse, and good logging creates an audit trail so you always know who deleted what and when. Do not skip these steps.
So as you go off and design your own APIs, here's the final thought I want to leave you with. When you delete data, is it a final farewell or is it just a see you later? Your choice between a physical and a soft delete, it's not just a technical one. It fundamentally shapes the story of your application's data, its integrity, and your ability to recover from mistakes. Choose wisely.